Okay, everybody, I have 11 o'clock Eastern time on my end. My name's Angie Inietti, and I am one of the forecasters at your National Weather Service office in Jacksonville, Florida. The presentation that you're joining us for is called the SKYWARN Storm Spotter class, and this is a program that's put on by National Weather Service offices all across the country, and the goals of the class are really twofold. Number one, we love to increase your local weather knowledge and give you some guidance on how to monitor for local upcoming weather hazards, and also some recommendations on how to appropriately respond and react when severe weather does threaten you. And the second goal of the class is to educate you on ways that you can relay your ground truth weather reports to us back at the office. Your weather intel to us really helps us out when we're working severe weather events or strong weather events, in giving us that information of, is the hail really reaching the ground? How big is the hail? What kind of damage could the strong winds be doing? All that information is really helpful to us back at the office when we're working severe weather operations. The number one goal always is your safety. We never are asking you to even go outside to try to see what type of a weather event occurred, but we always want to make sure your safety is of utmost importance. But when you can safely do so, relaying that intelligence back to us at the office is very helpful. So we are doing audio a couple different ways. Hopefully most of you can hear me through your PCs, and some of you have actually dialed into our phone line as well. So we're going to be offering audio a couple different ways. During the presentations, I need each of you to be your own IT support. I'm not going to have an open line to ask questions and interact right now through the talk, but we will open it up at the end for questions and interaction. And if you do have a question and you're hearing me through the computer audio, or even if you're dialed in through the phone line, it would be great to post that in the chat interface, and I will address that at the end of the presentation. Okay, so with that, let's go ahead and get started. Okay, so like I said earlier, we have a couple class goals. Number one is to help increase your local weather knowledge. We're going to show you some tools and talk about some observational skills to help you proactively monitor and appropriately respond to potential weather hazards in our area. And we're really going to focus on severe thunderstorm hazards, but we'll also talk a little bit about tropical. And then number two, our other goal is, when safe to do so, it would be really helpful to us if you could relay your ground truth weather reports to us back at the office, to the National Weather Service. So in this presentation, we're going to cover 5 main areas. The first one is we're going to talk about the National Weather Service and the support services that we offer you for getting your weather information. And then we're going to talk about watches and warnings, thunderstorms, and severe weather associated with thunderstorms like hail, damaging winds, and tornadoes. And then I have a little section on tropical hazards. Since we're in that neck of the woods, we need to address tropical potential in our area. And then towards the end, we're going to talk about some ways that you can monitor weather coming in through some internet tools, and then ways to report your information to the National Weather Service. Okay, so the National Weather Service, we are a federal agency, and we fall underneath NOAA. That's our parent organization. NOAA is the National Oceanic and Atmospheric Administration, and NOAA falls underneath the Department of Commerce. So we are a federal agency, and our main mission is to provide weather forecasts and warnings for the protection of life and property. So no matter where you go in the United States, including Alaska, Hawaii, Guam, and Puerto Rico, there's a weather service office staffed 365 days a year, 24 hours a day, with 2 meteorologists who are on duty. And we are constantly keeping a weather watch over our area of responsibility. And the map that you see there are all the different Weather Service offices' area of responsibilities. We call these county warning areas. And so in total, there's 122 Weather Service offices, field offices, like the one that I work at in Jacksonville. So you can kind of take a look there in Northeast Florida, Southeast Georgia. That's the National Weather Service's area of responsibility. We have 29 counties that we always maintain a weather watch for. But in addition to always, kind of keep an eye out for severe thunderstorms or fog, or, we've got some winter weather, it's the freezes and frost that we've been having recently. So it's our job to put out that information to all of our different partners, including you all, but we also work with federal, state, and local government agencies to let folks know what type of weather hazards could be impacting our area, and so you can prepare and respond appropriately. And the main Weather Service website is weather.gov. And through that main interface, you can actually click on a map of basically the county warning areas that you see here on this map, and you'll be taken to the local Weather Service homepage. And we'll take a look at that here coming up. Okay, so the local National Weather Service Jacksonville website is weather.gov/JAX. And this is a zoomed in map of my office's area of responsibility. So like I said before, we are always maintaining that 24/7 weather watch over our area of responsibility. And so let's say, for example, we have a thunderstorm develop. Well, it's our office's responsibility to monitor that storm, interrogate it, see if could it become severe or not, could it have large hail or damaging winds, is it rotating, does it have tornado potential, and if necessary, it's our job to put out a warning on it. There's a little example of a red polygon warning on that storm coming in at us from the Gulf of Mexico. So in addition to keeping that weather watch, we are constantly producing a variety of forecast products. These forecast products range from what we call the public forecast, telling you, hey, it's partly cloudy today, we've got highs in the 50s and no chance of rain, to other types of very specialized forecast. We put out aviation forecasts for different airport terminals in our area. We provide marine forecasts out to 60 nautical miles offshore into the Atlantic Ocean. We provide fire weather forecasts for our forestry partners and environmental protection agencies, all that good stuff. So we do provide detailed forecasts for a variety of customers while constantly maintaining that weather watch over our area of responsibility. So our office, Jacksonville Weather Service office, is located up at the International Airport in northern Duval County. We're co-located with the Air National Guard complex, if you're familiar with the airport set up there. So there's a picture of our office, and then on the right side there is a picture of one of my fellow teammates there, Andrew. So the inside of our office is, tons of computers and workspaces there. And like I said, there's always at least 2 of us on duty all hours of the day. But when we are ramping up for a larger event, like a severe weather event, like a squall line of storms coming in, or tropical operations, a lot of us will report to the office and spin up for operations. So a lot of our work starts ramping up for the event, where we provide briefings and interviews and whatnot for some of our core partners. We work very closely with emergency management for all of our counties, and we'll be there from well in advance of the event impacting to wrapping up afterwards as well. So we will go in and report to the office. You can kind of see a little bit in that picture there of the office. We're kind of built like a bunker. So if we have a tropical cyclone impacting our area, we have hurricane shutters that we put down, and we're there to ride out the event, to keep that weather intelligence going out for the goal of protecting life ultimately. So I work at a field office, and you just saw a picture of our field office there, but there are national centers that work with the Weather Service, or actually are part of the National Weather Service. And these national centers host meteorologists and scientists that really specialize in certain areas of forecasting and providing weather outlooks. And the two more common ones that you may have heard of are the Storm Prediction Center, and that's the agency on the left side of the graphic there, and then the National Hurricane Center. So let's talk about the Storm Prediction Center first. The Storm Prediction Center, they're based in Norman, Oklahoma, and they are staffed with meteorologists who really dial in on where the ingredients to potentially produce severe thunderstorms are coming together all across the country. And so they provide these convective outlooks, which you may have seen. A lot of our media partners like to showcase these, and we will use them as well in some of our local briefings that we do. And the scale of these convective outlooks basically gives you an idea of what part of the country is most prone to having, number one, thunderstorms, which are indicated by the light green color, and how dangerous and how, what's the coverage of thunderstorms today? Are we expecting a widespread severe weather outbreak potentially with tornadic storms? Well, if that's the case, then we're probably going to see that moderate and high risk of thunderstorms across the area. So the severe convective outlooks can be a really great heads up tool. And like I said, we'll use these in our local briefings, but you can also check this out through the Storm Prediction Center website, and their website's listed up there, spc.noaa.gov. The other national center that I'm sure you're familiar with is the National Hurricane Center, and they're based in Miami, Florida. And there's their website right there. And the National Hurricane Center has forecast and monitoring responsibility for tropical cyclones all across the Atlantic basin, including in our neck of the woods. And when I say tropical cyclone, that's kind of an umbrella term for tropical depressions, tropical storms, and also hurricanes. And so the specialists at the National Hurricane Center, they are really focused on the storm itself, the storm size, the intensity of it, and also they produce the storm forecast tracks. And they're really looking at kind of the broad scale, the ingredients to help steer the storm, the ingredients in the atmosphere that help intensify the storm. Now, in both cases with the Storm Prediction Center and the National Hurricane Center, even though they're keeping kind of a regional or national overview of whether it's severe storms or tropical cyclones, they do work very closely with the field offices, like our office here in Jacksonville. So, our job at the local forecast level is to, see what these national centers, kind of the guidance they're providing, and then we downscale that information for our local area. So let's say, for example, the National Hurricane Center, they're putting out their products on a tropical cyclone, and in this case, this is a tropical storm Dorian at the time. It's our job to, work with the Hurricane Center, and then we see, okay, well, based on their latest forecast track and the latest storm intensity for Dorian, what does this look like in terms of storm surge for the Jacksonville area or the Southeast Georgia coast, or how much rainfall could we get over the St. Johns River Basin? So it's our job at the local office to really downscale that information and give folks what the impacts could be given kind of the overview track of the storms. Okay, so one of the most important things we're going to talk about today is understanding the difference between watches and warnings. All right, so we're going to really focus on we're going to focus on severe weather watches and warnings for the majority of our spotter course here. So we're going to talk about tornado watches and warnings, and also severe thunderstorm watches and warnings. So when you hear that a watch is in effect, or this is on the left side of your screen there, it means that the ingredients are coming together in the atmosphere for severe weather to possibly form, okay? And in the graphic that you see there on the left side, all of the counties that are outlined in red in that example are underneath a tornado watch. So you can see that watches include a large area, And they're like a heads up product. Like, okay, for the next several hours, a lot of times the watches are in effect for about 6 hours. For the next several hours, the ingredients are coming in place across us where severe storms could possibly form. So let's stay abreast of the evolving weather situation, okay? A watch does not mean to duck and cover in the closet for the next 6 hours, okay? But it does mean to, you can still go about your daily life and your daily plans, but keep an extra watch on that weather coming in, okay? Because if a storm does develop, it could become very dangerous. It can become severe very quickly. So a watch is a really good heads up tool. Now, a warning, which is indicated on the right side of your graphic, means that a severe thunderstorm has developed, and that it's imminent. That danger from that storm is imminent. So if you're in that warning, and a lot of times your cell phone will notify you now that you're within that warning box. If you're within that warning and that storm is approaching you, you need to get to your safe place. You need to seek shelter immediately. Okay, so the watch is like, hey, monitor, heads up, the ingredients are coming together, and then the warning is get to your safe place. Now, can you have warnings without a watch in effect? Absolutely. A lot of times our watches are issued when, we're expecting pretty widespread coverage of storms coming across our area. So like in the graphic that you see on the left side of your screen for the watch example, that's a line of thunderstorms, kind of that broken line where you see kind of the splotches of red and yellow in there. That's what we call a squall line. So that's a well-organized line that's pushing across southeast Georgia and northeast Florida. But we could certainly have warnings when we don't have a watch in effect. I mean, maybe the storms are not expected to be widespread, severe strength, but we can still certainly put out those warnings. So just remember, watch, heads up, warning, take shelter immediately. Okay, now we actually do have pretty strict criteria on when we decide to issue a severe thunderstorm warning or even a tornado warning. And again, the warning means that you need to get to your safe place immediately if you're in the path of those storms. So the graphic that you see over on the left side now is actually showing us a line of thunderstorms. And we have a yellow warning polygon there for a good portion of St. Johns County, all of Flagler County, Putnam, and Marion counties. And so what we're trying to indicate in this warning is that as this line of storms come through, folks need to get inside, away from windows, because we're having some pretty intense winds. So for us to pull the trigger on a severe thunderstorm warning, the storm has to be capable of producing either strong winds of 58 miles an hour or more, strong wind gusts of 58 miles an hour or more, and or large hail of an inch in diameter or more. Okay, so both of these things don't have to be occurring at the same time, but at least one of them has to be expected when we issue a severe thunderstorm warning. Now, could sub-severe winds cause damage? Absolutely. Your trash cans are going to blow down the street. Your trampolines could get lifted in your yard with 30 to 40 mile an hour wind gusts. But for the warning events, those are the ones that we're expecting to cause more significant damage. And that's why we have that higher threshold for the wind speeds there. Now, we'll pull the trigger on a tornado warning if we can see rotation developing and intensifying in thunderstorms and starting to lower down to the ground. We'll pull the trigger on a tornado warning in that case. Or if we get a ground truth from a trusted resource like you guys and girls as a storm spotter, letting us know that, oh my gosh, we do see a touchdown, it's happened. So we have pretty strict criteria from when we pull the trigger on both severe thunderstorm and tornado warnings. And again, this is where you need to get to your safe place immediately if you're in the path of those storms. So one of the tools that we use, well, probably one of the most important tools that we use to help us interrogate thunderstorms is called the Doppler radar. And we have a radar actually right outside of our office up at the Jacksonville International Airport. And the radar, there's an image there on the bottom left of your screen. Inside that white dome is a dish. It looks like a satellite dish. And now we're going to kind of reference the little animation there that you see at the top of your screen. So the satellite dish sends out these pulses of energy into the atmosphere, radio wave energy. And when these pulses hit a target, like a raindrop in that animated example, some of that energy bounces back to the radar. And the radar dish is able to map that, okay, we have precipitation over here. I'm sorry, the dish is actually rotating around in a circle as well, 360-degree circle. And it sends out these pulses of energy and it listens for some of that energy to bounce back to it. And so the radar is able to map that, okay, we have rainfall over here, and based on the density of that target, is it a big fat raindrop, or is it a real dense piece of ice? Is it a piece of hail? Based on the density of that target determines how much energy bounces back to the radar. So the radar is able to map where we have precipitation, but it's also able to gauge how intense that precipitation is. And so the radar product that most of us are familiar with is called radar reflectivity. And an example of reflectivity is that very kind of bottom central animation there that you see, where it's most of the southeast region, and we actually have a tropical cyclone in the Gulf of Mexico there. But that is showing us radar reflectivity. So that's the one that most of our TV friends show, and most of the product that we pull up on our cell phone apps that we look at. So it's telling us where the most intense precipitation is. Now, the radar can also, after it makes a full sweep of the atmosphere, it will tilt up and make another scan of the atmosphere. And that concept is depicted in the image that you see there on the top right of your screen. So we call these elevation levels. So as the dish moves around and makes a sweep at 360 degrees, a full scan at that elevation level, it will complete its scan, and then the radar dish will tilt up and it will make another scan of the atmosphere all the way around. And so what this tilting ability enables us to do is we're able to get basically a vertical profile of showers and storms across our area. And that's really important because, you know, not only are we looking at these cells, these storms kind of, you know, two-dimensionally, you know, north, south, east, west kind of view, but we also, I mean, it's so important to see how they're evolving three-dimensionally, you know, as we go up into the atmosphere. So we can see, you know, showers just start out real shallow and low to the ground as showers. And then we can see those cores in the storm start to punch up higher into the upper levels of the atmosphere, and we can start to see hail start to develop in the upper levels of the storm. So the tilting, the scanning vertically is very important. So we can see how these storms are behaving, how they're evolving. Now, because this is a Doppler radar, the Doppler effect is a term in physics, and basically the Doppler effect is detecting a change in frequency of something. And for us in the weather world, what that basically translates to is we're able to gauge the motion of these raindrops or hailstones in the atmosphere, meaning that we're able to see, kind of get a gauge of what the winds are doing in the atmosphere. You know, how fast is that raindrop moving towards the radar or moving away from the radar? And that gives us a product called radar velocity. And that's the kind of the more splotchy image that you see down there on the lower right of your screen. And this is can be a trickier product to interpret. For radar velocity, it's always really important to know where the actual radar site is located. And in this case, the radar is actually located down kind of in the bottom left corner of that image on your bottom right of your screen there. And where you see green is really strong winds blowing towards the radar. And where you see that red color, especially that hot pink color there, kind of right in the middle, right next to the green, those are strong winds moving away from the radar. So if you can kind of get a sense of, we have really tight counterclockwise rotation going on right here. And if we see that rotation, kind of that green and red, kind of right next to each other in the mid-levels of the storm, that's called a mesocyclone. That can be a precursor to a developing tornado, possibly a strong tornado. And if we see that rotation start to tighten up and lower down a little bit closer to the ground there, and environmental conditions are supportive, that could be enough evidence there for us to go ahead and pull the trigger on a tornado warning without even getting a ground truth report, which is ideally what we want, right? We want to get the warning out before anybody sees an actual tornado so folks can get safe. So basically using the Doppler technology gives us an idea of what the winds are doing in the atmosphere around a storm and also within the storm, you know, what kind of winds are going on in the storm itself. So the radar is a really powerful tool. I know we've had some changes to our available radar online through the Weather Service. The main radar website is radar.weather.gov. It can be kind of slow, pretty slow at times, but they are working at the you know, kind of the national end to try to continue to improve this. There are more products available for users to look at through this new interface, and you're able to zoom in and do some nice mapping overlays, but it can be slow, and I know that at the national level they are trying to improve that. If you do not have an application for your phone for radar imagery, I think it could be a very useful tool. You know, I don't have a specific one that I can really recommend. The Weather Service doesn't have an app right now, but you can, it's all the data is coming from the Weather Service radars. But if you do choose to download a radar app on your phone, there's plenty out there that are for free. Consider enabling your GPS on your phone, because what that's going to do, if you get a radar app that shows your location, like a little dot where you are relative to storms coming in or near you, that can be really powerful because you can see, you know, what's your imminent risk of thunderstorms impacting your area. So just consider enabling your GPS on your phone if you do choose to get a radar app. Okay, we talked about this a little bit earlier, different internet resources, and I showed lots of different websites. The main website that I recommend for all of you to use is the weather.gov website, and then from all the different weather products I show you in this presentation, you can get access to those through that main weather.gov website. That's the National Weather Service, their main hub. It's a really great website, especially if you're traveling or you have family or friends in another neck of the woods and you want to kind of get an idea of, you know, what kind of weather could you have when you travel, or what kind of weather your family and friends can have, because this is a clickable map. So once you go to the main weather.gov website, if you click on the region of the country that you're interested in, it will take you to that local Weather Service homepage. And we have a little example there of our weather.gov/JAX homepage. And this is where at each individual weather forecast office homepage, you'll get your more dialed in local forecast. Okay. All right, so now in our second part of our talk, we're going to talk about thunderstorms. We're going to actually go in and talk about the weather now. Okay, so thunderstorms. We are in what we deem the lightning capital of the United States here in the Southeast, and especially the Florida Peninsula down there. Well, why is this? Why are we in such a lightning prone neck of the woods in our country? And if you have lightning, well, you have a thunderstorm. All thunderstorms produce lightning, whether they're severe or not. It's part of the definition of it being a thunderstorm, is it has to be able to produce lightning. Well, thunderstorms need three key ingredients to form. The first one is you need moisture. You have to have moisture, water vapor in the atmosphere for clouds to even form, let alone a thunderstorm. And because Florida and South Georgia, because we're so close to the Atlantic Ocean and the Gulf of Mexico, and even we have the Florida Straits to our south, anytime we get a An easterly wind, meaning that we're having a wind blow across our area from the Atlantic Ocean, or if we have a west-southwest wind coming at us from the Gulf of Mexico, or even a south wind coming up across the Florida Straits, we have wind flow that is moving across bodies of water, and that air that was over the bodies of water actually takes on moisture, and so we get that influx of moisture that comes at us across our region from different moisture sources. So a lot of the times, unless we have a kind of a dry northerly flow across us, most of the times our flow across our region can be moist. We have pretty good moisture sources around us. The second ingredient that we need for thunderstorm formation is called instability, atmospheric instability. And this is where you have kind of a natural vertical mixing in the atmosphere. So from the surface up, higher up into the atmosphere. And the red arrow there underneath instability is trying to illustrate that naturally, when you have air that's down near the Earth's surface, and the Earth gets warmed up by the sun, and the Earth radiates that heat towards the air closest to the Earth's surface during the course of the day, that warmer air wants to rise up. It's more buoyant. It's lighter than the colder air that's higher up in the Earth's atmosphere. Okay, so as that warm air rises up during the day, or sometimes at night with a front, as that warmer air rises up into the atmosphere, if it has moisture in it, it's going to start to cool and condense and form clouds. Okay, so we have to have that instability in place. We want that colder air to sink downward towards the Earth's surface, which helps force that warmer air upward. Okay. Now, to really initiate thunderstorms, we can have moisture and we can have instability, where we just have some puffy clouds outside, right? That's a very typical picture if we think of a normal warm season day across Northeast Florida, Southeast Georgia. You know, let's go into like June and July, and it's 10 or 11 o'clock in the morning, and we look outside. Well, we have these little white puffy cumulus clouds, right? They're not very tall. They're not what we call vertically developed. They're not thunderstorms, but it's warm and sticky outside, and that warm, moist air down near the Earth's surface is rising up, and it's basically the Earth is steaming, if you think of it that way, during the morning hours, and that warm air rises up and it cools and condenses, and it forms those little white puffy cumulus clouds. Well, into the afternoon hours on a typical warm day for us here, those little puffy clouds can get taller and bigger and more vertically developed, and at some point they may become thunderstorms. Well, what's happening into the afternoon hours is typically we're starting to get the sea breeze fronts that set up. This time of year, we can get cold fronts that come into the region. And so what these fronts do, and that's indicated by that little lift circle there, that's a cold front schematic. When you have fronts that set up, the fronts act as like a focusing mechanism that helps squeeze the air together, and it really can accelerate the upward growth of these clouds. Okay, we have moisture, we have instability in place, but what we need for these showers and thunderstorms to grow vertically is a source of lift. And during this time of year, that source of lift comes in the form of frontal boundaries, cold fronts and warm fronts. Okay, when we have fronts coming in, that really helps lift the air ahead of the fronts, and we can get the thunderstorms that develop. During the warm season, we can have the sea breeze fronts. They set up along the coasts of both the Atlantic and the Gulf of Mexico. We can also get lake breezes and river breeze fronts that set up, and those boundaries can serve as foci for thunderstorms to develop. So all thunderstorms have lightning. And when we talk about severe thunderstorms, we're specifically talking about storms that are capable of producing large hail, damaging winds, and even tornadoes. Okay, so I know this can be kind of an overwhelming graphic here, but basically what we're doing is we're walking you through the stages of a typical thunderstorm developing, okay? And so let's talk about the image that you see on the left side of your screen, okay? This is the baby stage of a thunderstorm trying to develop. Okay, this isn't even a thunderstorm yet. So what we see here is basically the warm, moist air that occurs down near the Earth's surface. As the Earth gets heated up during the day, or if the atmosphere is favorable, it will get warmer at night if you have a warm front coming up across the area. But basically, where you have warm air down near the surface, as that air rises up, that creates something we call an updraft. That's a vertical extension of air rising up into the atmosphere. If that air has moisture in it, it cools and condenses and begins to form clouds. Okay, now go to the image now in the middle of your screen. Now, if the conditions are right, say we have a front coming in, that updraft indicated by the red arrow will continue to accelerate upward into the upper levels of the atmosphere. And once we start to have ice introduced into the upper levels of the cloud that's starting to form, remember, the higher up you go into the atmosphere, the colder it gets. You're getting farther away from the atmospheric heat source, which is actually the Earth, right? The Earth is absorbing that sunlight, that radiation, and then giving it back off to the air that's in our atmosphere. So the atmosphere is not necessarily warmed by the sun. It's warmed by the Earth itself. The Earth is what's radiating that heat. So you always have your hotter temperatures down near the Earth's surface, and then your colder temperatures as you go higher up into the atmosphere, as you go higher up with altitude. So as that updraft punches up into the upper levels of the atmosphere, and we start to get ice introduced in the upper levels of the atmosphere, it's the introduction of these ice particles that rub up against each other, and they cause electrical charge separation. And when these positives and negatives want to try to hook back up, that creates lightning. So at this point, we have a mature thunderstorm in the mature stage, because we're starting to have lightning that's being generated in the thunderstorm itself. Okay, so the updraft is still punching up into the upper levels of the atmosphere, and at some point, that updraft, there's ice aloft, there's hail aloft in the upper levels of the thunderstorm. At some point, that mass that's elevated in the storm becomes too heavy for the storm for that updraft to support any further. Or sometimes the storm will move over an environment that's not as moist or not as unstable. The ingredients to keep the storm going don't coincide anymore. And at that point, the storm can begin to dissipate. But a lot of times for us, what happens is that updraft, that mass of hail and heavy rain and whatnot aloft in the upper levels of the thunderstorm becomes too heavy for the updraft to support. And so we begin to produce a downdraft. And that's the rainfall, the potentially hail coming down towards the Earth's surface. And it's that downdraft of air that brings the rainfall down towards the ground. So in a mature thunderstorm, you have both an updraft and a downdraft. And you can do a cross section through all thunderstorms, and you always have these main two currents of air, the updraft and the downdraft. Now, note down underneath the mature thunderstorm, do you guys see that little, it looks like a cold front, basically, that little blue line with little blue triangles on it? There's a feature that happens once that downdraft hits the ground, okay, where the gray area down near the ground, that's where the rainfall is. But another thing to actually start to kill off the thunderstorm is, the storm has to move over, or the environment has to become less favorable. We have to lose one of our ingredients to keep the thunderstorm going. What can happen with a lot of our storms, especially during the warm season, our sea breeze storms, is that colder downdraft air. Remember, the cold air is always trying to get down towards the ground, get to sink. That colder air can push out along underneath the thunderstorm. And that's a feature that we call a gust front, okay? And I'm sure you all have experienced a gust front. It's when there's a storm near you. It's not raining on top of you. That would be near the downdraft area. But it's raining near you. There's a storm near you. But all of a sudden the temperature drops, the wind picks up, and you get the temperature drops suddenly 5 to 10 degrees within a minute or two, and the wind really picks up. That's what we call the gust front. And so when this gust front can push out along the low levels underneath the thunderstorm, it can actually cut off the updraft circulation. And that's when the thunderstorm would begin to dissipate. And that takes us to our third graphic over there. So note, in this stage of the thunderstorm, the storm is dissipating. It doesn't have any more low-level inflow or juice or updraft going up and feeding the storm. It's all downdraft dominant. Now, you could still have rainfall. You could still have some lightning going on with the storm in this stage. But in terms of the storm really, rocking and rolling there, it's dissipating. It's starting to weaken, and it's fizzling out. And you can see that the storm itself, it erodes from the low levels upward into the upper levels of the atmosphere. So those are the three main stages of thunderstorm development. Now, thunderstorm hazards. We talked about how all thunderstorms could be potentially dangerous because all of them have lightning. And, if you live in our area in the Southeast, I mean, we've all done it where, we're busy outside, or we've got an event and, we know thunderstorms are in the forecast, or we hear those rumbles of thunder, but we still stay outside. Well, that is a huge danger, because a huge lightning danger, because if you're close enough to hear thunder, you are close enough to be struck by lightning. So the storm doesn't have to be producing hail or tornadoes or winds for it to be a danger, because all of them have lightning. So if you're close enough to hear lightning from a storm, you need to hear thunder, you need to make plans to go inside. As spotters, you can take it a step even safer. And, first of all, know that thunderstorms are in the forecast that day. But if you start to see those tall, white, puffy clouds starting to develop, well, that's your indication that your thunderstorm potential, lightning hazard potential is increasing. So, go ahead and use your spotter skills to, hey, I think we're probably within an hour here of these things, really starting to produce thunder. Let's go ahead and wrap it up at the beach, or let's go ahead and, get everybody in from the game today. Let's go ahead and just take it on inside before you even hear thunder, before the first lightning bolt happens. Now, for a storm to be defined as strong in our area, well, it's probably putting out some hail. And we're having some stronger wind gusts to that 40 to 50 mile an hour range. And then for it to be defined as a severe storm, we have large hail, and technically it's over an inch in diameter, and that's the official definition of a severe thunderstorm. And you have really strong winds of 58 miles an hour or more, and if it's producing a tornado, well, you got a severe storm. Okay, so kind of a lot of text here coming up on these next slides, but basically what we're trying to do is give you some safety recommendations. So the first one we're going to talk about is lightning, but then we also have some safety recommendations for good shelter options for hail and winds and tornadoes from thunderstorms. So it's a lot of text, but you can really use this as good guidance. So Florida leads the country in lightning fatalities just about every year. And you can see these statistics here run from 1959 to 2017. So lightning is a huge danger in our area. Why? Well, we're the thunderstorm capital of the United States. We have a little safety saying, when thunder roars, go indoors. That's illustrating the fact that, hey, you're close enough to hear thunder, even if it's a distant rumble. You're at risk of being struck by lightning. You're close enough to that storm to be struck by lightning. That image that you see there is a flagpole on a golf course, and where you see orange grass or that brownish grass is actually dead fried grass. And so what happened is lightning struck the flagpole there, or the golf marker pole, whatever you want to call it, and the current of that lightning strike traveled along the ground, emanated well away from where the initial contact from the bolt was, and it electrified the grass there. And so this image really shows you how, you hear stories of, an athlete on a field, soccer field, baseball field, whatever. One person could be struck by lightning, or perhaps maybe even just a pole. Maybe it's a light pole near that field gets struck by lightning, but then other folks in the area go down. Well, it's showing you that that electric current from that contact strike travels well away from where the actual lightning bolt hits, and it impacts living things in that path. So, it's better just to go ahead and, scan that sky. We'll know the forecast, right? Is there a chance of thunderstorms in my area? Are the ingredients coming together that thunderstorms are possible? Well, if yes, then okay, you need to keep a heads up of how that sky is going to change the course of the day. Check your weather app. If you start seeing blobs of orange and red starting to increase, well, you got thunderstorms probably starting to pop. And if you are sheltering from a storm, staying outside in exposed areas like a picnic shelter or under a tree is a terrible location because you're a tall object in an open area most likely, and that's where all that electric current is going to build up underneath the storm. So it's better just to get inside a well-constructed, grounded building and avoid windows and access areas to outside, and just hunker down. Wait till that storm passes and your lightning threat decreases, and wait until about half an hour, 30 minutes or so until you go back outside after you hear that last rumble of thunder. Okay, so that's being super proactive, very safe, because lightning is one of our #1 killers here in our region. Okay, so now we're going to talk about severe weather from thunderstorms. So, flooding rainfall. And can we get flooding from not even a thunderstorm? Yes, absolutely. So flooding occurs a lot of times in our area when we get a storm that doesn't move. It doesn't have a lot of storm motion to it, and it can drop, 4 inches in an hour or more in some extreme cases. Or if we get storms and even showers that follow the same path, say we get one storm or one shower after another, this is called training, and where they follow each other like little train cars, right? So all that rainfall can gradually build up over a course of a day or, several hours. Well, that can produce flooding. And, our flooding, we have a little saying for flooding as well: turn around, don't drown. Even if it's an area of a road or a dirt road that you're used to driving, and you kind of feel that, oh, it's not that bad, it's not flooded. Well, we could get sinkholes that develop. There could be debris in that area of flood water. It's just better not to go through it. It's safer to find an alternate route. Is it inconvenient? Yeah, sometimes it is. But is it having your safety or those in your vehicle safety as, #1 priority? Yes, it is. So consider finding an alternate path, going around the water. Turn around, don't drown, find a different way around it. Okay, hail. Hail from thunderstorms in our area can and does happen. Typically, these are from some stronger storms. So when it's 90 degrees outside in the summertime, and we get these huge storms that are 50,000 feet tall, there's hail in them. There's hail aloft. And a lot of times when that core from the storm begins to descend down towards the surface, that hail melts as it's coming down where the temperatures are warmer in the low levels of the atmosphere. And we just get big fat raindrops down at the ground or really heavy rain. But sometimes conditions are favorable. The freezing levels in the atmosphere and the hail growth area in the storm is vigorous enough and low enough down to the ground where the hailstones can actually maintain themselves as pieces of ice. And hail goes through a process called aggregation. And this is where you get kind of some of the funkier looking hailstones. A lot of times they're not these perfect round balls. They look pretty gnarly. They can be kind of nubby, if you will. Those are some examples of hail, pictures that were taken by some of our local spotters. That image there in the kind of on the top left is about ping pong ball size hail. And then the image in the middle there, middle center, is about baseball size hail. That was actually taken out towards Atlantic Beach one summer. So we can get pretty large hail in our area. So the process for hail growing is basically depicted in that image in the center middle of your screen. And the process is called aggregation. So let's follow a raindrop, following the yellow arrow up through number 1. Let's say we're getting inflow going up into a storm, okay? And that warm air is going up into the storm. It cools and condenses and saturates, and now we have rain. Okay, we're following number 1, number 1, number 1. And then that starts to cool off, that raindrop freezes, it gets above the freezing level, and now we have a piece of ice. It's actually a piece of hail now. And that hailstone can get tossed back down a little bit. You know, we have our main updraft and our main downdraft in a storm, but there's little baby eddies up there. So the hail can drop down a little bit. Now we're following number 1, going down to number 2. And that hail can start to melt and it gets a layer of water around it. And then the hailstone can get tossed back up again in number 3. So we're following number 3, number 3. And as it starts to refreeze, that layer of water starts to refreeze, it can stick with another hailstone and they refreeze together. And this circulation from 1 to 2 to 3 can keep happening until that updraft, that main updraft in the storm says, all right, you're too heavy, or the hail itself is too heavy, and it starts to fall down towards the ground. Sometimes a strong wind in the upper levels of the storm can actually eject the hail out of the grow area, and that hail can fall down through dry air and not mix with rain. That's how we can get really big hailstones. But it's basically that process of aggregation that grows these hailstones from tiny pieces of ice to much larger ones. And then once it's too heavy, that hailstone will descend down towards the ground. Now, as a spotter, number 1, when it's safe for you to do so, number 1, safety always. If you can call in your hail size report that you observe, it really helps us out. It gives us an idea of the hail that we're seeing on radar indicated, if it's actually reaching the ground. And so when you call in your hail reports, try to refer to the size of the hailstone as a common object. You know, we have 1/4 inch hail, not quarter size hail, but 1/4 inch hail. That 0.25 inch hail is referred to as pea-size hail. And then, you know, once we get to larger hail, that 1/4 size hail, that 1 inch in diameter, is what we define as severe size hail. So we certainly need a warning out, severe thunderstorm warning on that storm. But we can go all the way up to softball size hail. We've got one of my friends in Flagler County has a great story about softball size hail that impacted a huge part of most of Flagler, inland, western Flagler County. And as the storm tracked across Flagler County, it dropped large hail first, and then by the time it started to move offshore of the coast, it was down to about 1/4 size hail and then dime size hail. So we can get very large hailstones in our area. It's not common, but it does happen. But when you call in your report, try to refer the size of the hailstone as a common object. Don't go outside when it's hailing. That's our little safety disclaimer right there. Okay, so now we're going to talk about winds from thunderstorms and thunderstorm outflow winds specifically. And this is probably one of our most common thunderstorm. This is our most common damaging weather event from thunderstorms in our area. That's what I'm trying to say here. So winds from thunderstorms, we call these downburst winds. You may have also heard as straight line winds. It's basically the same type of weather phenomenon. Okay, it's basically the winds in the atmosphere in a thunderstorm begin to descend down towards the Earth's surface. As a lot of times, this is when the hail aloft, the mass in the upper levels of the thunderstorm becomes too heavy for that main updraft to support, and so the thunderstorm begins to collapse. And so this massive rain and hail begins to descend down towards the ground, and that current of air hits the ground at a high rate, a strong magnitude, and then that wind pushes out along the Earth's surface. And it's along that leading edge of that push that we can have some very strong winds. And so the radar image that we're going to look at first is the radar image that's on the left side of your screen. And we are seeing a line of thunderstorms, what we call a squall line of thunderstorms, pushing across southeast Georgia and North Florida. And all those yellow boxes, well, those are severe thunderstorm warnings in effect. I mean, we had widespread wind damage with this line of storms racing across our area. I have a kind of a pink circle there around a storm that's near Bradford County, kind of along a line, a portion of the squall line down in Bradford County. And what I'm trying to show you there is a radar feature called it's the start of a bow echo. And so what this is where you have a pretty uniform squall line like we have in our picture there. But if you start to see a little bit of the line starting to kind of push out, that red is starting to kind of angle out a little bit more compared to being kind of in a north-south oriented line like what we have in Nassau and Duval County there. If you look down in Bradford County, we see some of that red starting to kind of bow out a little bit. Well, that can be an indication of pretty strong winds coming down towards the surface along the leading edge of those storms. That's called a bow echo. Velocity image there, which, you know, we're not expecting you to try to interpret on radar, but just to show you kind of what we see on our end at the Weather Service for when we see a strong downburst hitting the ground underneath the storm, is we see this divergent pattern in the winds. Remember, the velocity is showing us what the winds are doing in the atmosphere. And so this is a storm that dropped a downburst across the south side of Jacksonville near University of North Florida. In green is wind flow towards our radar up at the Jacksonville International Airport, and that pink and red is strong winds moving away from the radar. And so where that little yellow arrow is right where we had this really strong downburst drop down, really strong current of wind down at the Earth's surface. And just a little to the west-southwest there of that yellow arrow, we had a spotter who had a home weather station, and they measured like an 80-mile-an-hour wind when that downburst pushed through. Now, downbursts, the winds, when they push out along the Earth's surface, they tend to level things in the direction that the high wind was traveling, right? So like our pine trees that we have around here, pine trees are pretty pliable, they're flexible, they're what we call a softwood tree, but the upper levels of the trees can actually snap. And they'll kind of be snapped in the direction that the high wind was traveling. Our oak trees are hardwoods, and you know, they're a little they're more susceptible to stronger winds, and so a lot of times the oaks that we have will be leveled and uprooted if it's a strong enough downburst wind event. So it's very uniform damage pattern with downbursts. It's not like a tornado damage pattern. Things aren't ripped up and strewn about or twisted. Downburst patterns, wind damage patterns, are usually pretty uniform and kind of radial in extent. A really good indication of strong winds associated with a storm that could be approaching you is a cloud feature that we have there indicated on the top right of your screen. It's called a shelf cloud. Now, shelf clouds, I said they could be strong indicators of strong winds. Well, I should take that back. They're not necessarily associated all the time with severe strength winds by any means. Now, shelf clouds are long horizontal clouds like you see in that image. They can look really wicked, very ominous looking, but basically shelf clouds are indicating the leading edge of a gust front from a storm. Remember how we talked about that rain cooled air comes down and hits the ground underneath the downdraft air of a storm, and then that cooler air underneath pushes out along the Earth's surface, and that's the gust front. Well, some of that air can rise up and cool and condense at a very low level right underneath the thunderstorm and create this long horizontal cloud called the shelf cloud. And the shelf cloud pushes away from the rainfall area of the storm. And so in this image here, you can actually see the rainfall behind the shelf cloud. So that shelf cloud, if we're on the beach, that shelf cloud is moving towards us. And once that shelf cloud moves over us, we're going to expect an increase in winds winds getting pretty gusty, right, blowing at our face, and then the onset of rainfall. So the shelf clouds can be an indication of some winds coming at you. And they can certainly be an indicator of possibly some severe strength winds, but not all the time, but definitely some winds picking up behind the gust front, and also the beginning of some rainfall for you. So safety recommendations with all thunderstorms, including downburst, wind thunderstorms, severe thunderstorms, is to stay in a well-constructed building, away from windows, away from doors. And the lower you are in a structure, the safer. The higher up you go, the stronger the winds with the thunderstorm are going to be. So you want to stay on the lowest level, away from windows. And you want to not necessarily be in large open rooms like a gym or a warehouse. The more walls you can put between you and the outside, the better when it comes to severe weather safety. Okay, so now a little bit about tornadoes. Tornadoes are violently rotating columns of air that can accompany a severe thunderstorm. We have an image there of a tornado over the water. When it's over the water, we call that a waterspout. That's actually from over the St. Johns River. Most of our local tornadoes are weaker tornadoes, EF0s to EF2s, but EF0s, EF2s can produce significant damage and can be life-threatening. So we want to take all tornadoes very seriously. If there's a tornado warning out, we need to get to our safe place. So just some classic radar signatures associated with very strong tornadoes that you may hear about in literature are called a hook echo, indicated by the radar reflectivity signature there. That's where you get kind of this, we're looking top down on a storm, that image in the top center of your graphic. We kind of get that curly Q shape in the radar reflectivity, and that's actually all the rainfall that's wrapping around something we call a mesocyclone that develops in very strong storms called supercells that are capable of producing long-lived tornadoes. So that hook echo shape is always a big heads up to us as radar operators to really monitor that storm. It could produce a tornado. It doesn't mean there's one on the ground when you see a hook echo signature, but it is an indication that the storm is getting organized. It could have a mesocyclone, and it's definitely something for us to watch. And a classic tornado signature for us on the radar is indicated in the image to your upper right there. In this case, the radar is kind of to the northwest in that specific image, and we have bright blue moving towards the radar. The cooler colors indicate really strong winds moving towards the radar. Then we see the white and the pink color moving away. So that's what we call a gate-to-gate rotation, and that's and in this particular case, that was an F4 tornado down on the ground. So that's what tornadic circulations look like to us as radar operators. Again, safety recommendations for tornadoes is to get in a well-constructed, strong building on the lowest floor. Talk to your family about, and even your coworkers, if we had to shelter in place with a tornado approaching us, or if we're in a tornado warning, where do we go? A lot of times we hear that it's a closet or a bathroom. Well, not all the time. Sometimes it could just be an interior room. For our family, it's actually our laundry room. It's kind of a hallway right off our laundry room. It's in the middle part of our home, away from windows, away from doors, and that's where we would shelter. So talk with your family, talk with those at work. Hey, if we need to shelter, where would we go here? Where's the safest place? And do that discussion before a storm threatens. Once you get to your safe place, if you're riding a tornado, it's advised that you get into something called the tornado crouch position, and that's exhibited by the two kids in the bottom right of your screen there. The tornado crouch position is where you get down and you crouch down and cover your head, and you're trying to protect all your vital organs and your head from any debris or any stuff that could get blown on top of you or fall on top of you. So, interior room, lowest floor, away from windows, crouch down and cover your head. So now we're going to talk about monitoring for thunderstorms and lightning potential. And we talked about this a little bit earlier, but basically 3 things that you can do as a spotter to stay abreast of your thunderstorm potential. Number 1, check the forecast. That's over on the right or left side of your screen there. Are thunderstorms even in the forecast? Well, if they are, is the Storm Prediction Center kind of given an overview that they could be, severe today? So you got some tools there to check out. Number 2 is check out radar. Look at radar reflectivity. If you see all cool colors on your radar screen, well, you have a pretty low imminent lightning danger, right? But if you start seeing blobs of orange and red starting to develop, well, your lightning threat is really going up. And then also look outside. Look at your clouds. What are your clouds doing? Are they tight little cumulus clouds that are staying very shallow and low to the ground, and they don't have really crisp edges? They're kind of wispy looking clouds, like the images that are on the bottom right of your screen. Well, if they are, then that's unfavorable for lightning. But if they look like they're building and your cotton ball clouds and your cauliflower clouds are looking pretty crisp and tall, well, your lightning threat is going up. So these are some tools that you can use to really help gauge your thunderstorm and lightning potential. Now, when we talk about severe weather notifications or any type of hazard notification, right, including severe weather, it's really important to have multiple ways of receiving warnings. Most cell phones now will automatically alert you of tornado warnings, flash flood warnings, and you can actually sign up through your county websites. Most of our local counties offer a alert notification message system now that you can put in, your home address, and it will notify you. You'll get a text or a call if your home is in the path of a warned storm. So please visit your local county emergency website to see what kind of alert notifications are offered. We can always get our notifications through our trusted media, through TV and radio. Some communities have outdoor sirens, not very many for tornado warnings, but we do have some in Southeast Georgia. But the key is to have multiple ways to receive weather notifications. Okay, our cell phones are great, and we carry them around like a extra appendage most of the time, but it's always important to have a backup. For our family here, we have 2 different weather radios that we use. Weather radios, they stay in silent mode, but when there's a warning issued, and if you're included in the warning, it will tone alert. It will let you know. So look into having multiple ways of getting severe weather alerts. Okay, now we're going to quickly talk about some tropical hazards in our area and ways you can monitor the tropics. So when we talk about tropical hazards, tropical cyclones in our area, we're talking about hazards of storm surge. That's that massive water that comes on shore when a storm gets near landfall, strong winds, tornadoes, and flooding rainfall. And then even days before we have any of those impacts, we really start to see deteriorating conditions on our coast and in our marine waters. So even days before and after a storm threatens, we can have dangerous rip currents, a really high amount of rip currents, beach erosion, coastal erosion, and very dangerous marine conditions for our mariners. So the tropical forecast program in the Weather Service, we alluded to this earlier, talking how the National Hurricane Center, the National Center, they forecast for the storm, the size, the strength, the intensity, and the path of those storms. And then we talked about how the local weather service offices, like the National Weather Service in Jacksonville, take these overarching storm forecasts from the National Hurricane Center, and then we tailor that down to local impacts across our forecast areas. So, based on this amount of rainfall, what could that do to our local rivers? Or based on this latest forecast and strength of the storm, how high could our storm surge get in our different communities? So, we work hand in hand with the National Hurricane Center on trying to provide the best, most updated, most realistic weather scenarios to work with. The key thing here is that we do not hype tropical events, or we try not to hype any type of weather events. You know, we want to give you the best information using the best, latest science available to help you make the best decisions for your family when it comes to tropical hazards. The most common product that we get from the National Hurricane Center that is really shown and is a very powerful tool, a planning tool, a preparedness tool, is the track forecast. And just really want to help everybody understand how to interpret this product. It is a planning product. It's not a reaction type of product. Like, you do not want to wait when the storm is on top of you to be looking at this product. Use this days in advance. And the way we use this product and what this means is it's the forecast track of the center of a storm, of a tropical storm or a depression or a hurricane. The storms themselves, you know, where the heavy rain is, where the winds are, where the storm surge is impacting, extends hundreds of miles out from where this white shaded area is showing us where the center of the storm could be. Okay, so at this time, this was for Hurricane Irma back in 2017, and we can see that this is a few days out from where the storm's expected to impact Northeast Florida and Southeast Georgia. And look at that white shaded area. Northeast Florida, Southeast Georgia, the coastal areas are not even in that white shaded area. But guess what? We're expecting hurricane conditions. We have hurricane warnings up for the coast here up to Georgia, and then tropical storm conditions. Let me go forward in time a little bit. And this is our next graphic that we have. Look where that white shaded area is. Remember, that's only for the center of the storm. And the accuracy of that is for about 60%, 66% of the time, saying that the storm is going to be in the center is going to be in that white shaded area. But if you're a local resident and you see this product came out at 2 a.m. on Monday morning, well, at 2 a.m. Monday morning, all of North Florida and Southeast Georgia was having tropical storm conditions. I mean, we were having surge on the coast. We were having historic rainfall, flooding all across the area. Parts of St. Johns River were flooding. So, you know, just as a reality check, that this graphic is not showing you where the impacts from the storm are expected. It's showing you where the track of the center of the storm is expected to go, but the impacts will extend well beyond the white shaded cone area. Tropical watches and warnings. When we hear that a hurricane warning is issued for our area or a tropical storm watch, those products are specifically dialed into the winds. Okay, they're not taking into account the rainfall amounts or the storm surge potential or the tornado potential. So I just wanted to kind of reemphasize that what those products are. Those are specifically calling attention to the winds, which is just one of many hazards from tropical cyclones. Okay. And a lot of times, you know, we are always interested to know what the official outlooks are. You know, oh, what's the National Oceanic, you know, what's NOAA's outlook for the hurricane season this year? Well, use those outlooks as just kind of a nice factoid, if you will, but do not base your seasonal preparedness on the outlooks. It only takes one storm for it to be a bad year in our area or for your area, right? And I have a couple of outlooks and the realities of the storms on the graphics here. 2016, the outlooks, you know, we had Matthew, which was a big year for us. In 2017, what was our storm? It was Irma, right? And that actually had the outlook that came out in May had an elevated chance of it being a near normal season, where a lot of our storms remained out over the tropical Atlantic, didn't impact land. But what do we remember? We remember Irma from that year. Okay, so, you know, just to recap real quickly here on tropics, It only takes one storm, so prepare every year like it could be your year. Get your supply kits ready in advance. Make sure your insurance policies are updated now. Do that now. The National Hurricane Center is great for giving an overview of the storm path potential, and then you dial into your local weather service offices for your more downscaled impacts from these storms. Okay, so we're starting to wrap up here our talk. Just want to go over some ways to monitor and report your weather observations, if safe to do so as a storm spotter, to your weather service offices. So to monitor the weather, we talked about a lot of great tools. Dial into your local weather forecast office website. That's ours there, weather.gov/JAX. We have a variety of briefing products available. We have a daily web briefing that we always update. That's available on our webpage, and we're active on social media, on Facebook and Twitter. You can like us and follow us on those interfaces if you like to do that. And the main thing here is, especially on social media, is to be cautious of unofficial or hyped up weather resources, and that's especially true for tropical events. You choose your weather resource forecast source wisely, okay? But there's a lot of really great tools that you have available online to monitor for upcoming potential weather impacts. During weather, when we're having watches and warnings, that's an example of a automated graphic that's tweeted automatically over our Twitter feed. And monitor radar. It's kind of hard to see there in that animation, but monitoring radar through the weather service will actually show you the warnings that are overlaid on specific storms, so you can see where you're at or where the warned storms are located. And this is a time, if you can, to relay weather information to us, and we'll talk about ways to do that here coming up. So always, 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 your safety is number one. We never want to put you in harm's way trying to get a weather report to us, right? If safe for you to do so, the easiest, fastest way to get a hold of us at the Jacksonville office is to call us directly. And there's an 800 number there for you, 800-499-1594, extension 1. And just go ahead and put that in your phones now. Write it down and put it in your phones. And that way you are calling directly our office. You will get a forecaster. You're going to get one of us on duty and relay your weather information, hail or wind damage, or if you see, a water spout. That information is really important to us. If you take pictures, you can share it with us through Facebook and Twitter. There's also an online spotter report form. That's good, if it's not imminent, like the next day, if you're talking to a friend and they had wind damage or something, you can send a report in that way as well. High priority weather to call into us as soon as safely possible. Obviously, we're going to want to know if you see a tornado or water spout. If you see wind damage or hail of any size, wind damage would be like trees down or damaged. If you see structural damage, like somebody's roof or shingles are missing, things like that would be really important to relay to us. If you see flooding, if you see water that's accumulated in streets, that's dangerous for vehicles to pass through, or if you see water that's accumulated and looks like it's going to flood a structure, that's really important for us to know. We need to do some type of warning product on those situations. So again, just to reiterate, the easiest way to relay your weather reports is just calling us through that 800 number directly. This is just a little miscellaneous other things that is nice to know about if you can. As a spotter, we like to get information on dense fog, which is defined as visibility less than a quarter mile. Tidal flooding and beach erosion, that flooding image there is from tidal flooding, from coastal flooding, not from storms and heavy rainfall. That's just from water inundation from a weather event that happened over the ocean waters, and it's increasing our local ocean levels or our flooding levels. And then winter weather. Oh my goodness, can we get winter weather here? Yeah, it's not very common, but we can. And this is actually one of our spotters up in Georgia, Hazelhurst, Georgia, took this for us They measured some snowfall for us, literally just taking a ruler outside and sticking it in some snow, telling us he had about 3 inches of snow with that winter weather event. So these are some other weather events that are helpful for us to know about if it's safe for you to call it in. So there's a lot of tools online. You know, this is just one spotter course that you all participated in, but there's some online tools that you can delve more into, not just learning about local severe weather hazards, but, you know, climate and clouds and more in depth about severe weather. So there's some really good tools available for you online. Spotter Field Guide is what the whole class that you just took was based upon, and there's an online guide for that. And then there's actually online spotter courses too that you can take through that entity called MET Ed, Meteorology Education. They have some really great resources there for you too.